morning.
Good morning, guys. I see some names here on the side. Definitely, it is not our entire class, unfortunately, but they are adding little by little because on my screen I can see small rectangles with your at least names. Some are coming with pictures, but on the side I see your names. Definitely, again, not many people are in presence right now, but I'm going to start. First thing, I would like to answer some questions which I received in form of emails because I wanted to answer this to entire class. I received just recently an email asking about a special grade treatment in your class, which is linked to your attendance. I never promised to drop 3 grades, and all this information is with all details is described in your syllabus, which I sent to you at the beginning of semester. I explained that in that syllabus, and I explained that in the class, and I do not mind to mention this again. I promised that if you have decent attendance, which means because your class is 4 units class, that if you, for entire semester, did not miss more than 7 hours of lectures, don't forget that each hour meeting is equivalent of 2 hours. I will drop 1 your lowest test grade and 1 lowest quiz grade. But what kind of quiz? We had 2 different types of quizzes. I am talking about so-called in-class quizzes, not quizzes which you had on your My Math Lab site. No, it is not in class so-called quiz. By the way, you have another one which is open and it will be closed today at 11 p.m. I opened this on Sunday for you. So now, what about another question coming from another student about my office hours? Ladies and gentlemen, this information is also in your syllabus. And at the beginning of our virtual meetings, we started having them, what was the date? March the 17th. Before that, on 16th, I sent everyone an information how to access my lectures on Zoom and how to access my office hours on Zoom. I keep, and for office hours and for my lectures, the same schedule which we had when we had face-to-face classes. So I have my office hours on Monday, Wednesday, and Friday, and again, everything is described in your syllabus. So before actually, maybe the best thing, before sending me that kind of emails, maybe you can do your part of job, actually searching for this information, because please read your syllabus again. Definitely, again, why I'm talking about that, trust me, right now I do at least 2-3 times more work than I usually did during our regular face-to-face classes, because it takes a lot of time to record these lectures and to upload that to YouTube and make this available to you. I'm extremely busy, so definitely I will try to answer all your questions, but when you should know the answer for that questions, please try to again do some kind of research, and please after that email you, because if you email me and I did not reply right away, it means it is something what you should know the answer for, and not because I'm trying to be a bad person trying to ignore your emails. I never ignore emails of my students or let's say colleagues or other people. I all the time try to answer questions which they ask me about in their emails. But again, for this type of questions, you should know answer long time ago. Thank you for your understanding. I would like to announce one important thing again. As you probably should know again from your syllabus, we are having right now the last week of semester. I'm going to right now, today, start with you section 4.1. And if I have time, I will go over section 3.7, I think. I hope I will, at least will be solving problems. But on the coming Thursday, which will be our last class, in the first part, you will have a test. You will have a test, and probably I will offer this to you through my math lab. So at quite a late evening on Wednesday, I will send you some details what to do with that test. This test will be for the material which we covered in sections from chapter 3, and it will be your last test in this class. But on coming Thursday, I'm not planning to devote entire meeting to our test, which you will be taking on coming Thursday. I will offer it to you at the first part of the class. In the second part, I will explain with all details solutions for that test. So you will know the correct solution and answers, and I will try to answer all your questions because of special circumstances for this semester when we were put in a very difficult situation. I will not have time to do detailed review for coming finals because of the lack of time, but you will be having your final on May 21st from 11:10 a.m. to 1:40 p.m. And I will definitely release details about that final closer to the day of the final. So please, if you have any question right now, I really encourage you to ask me about anything what you need to ask me about. Can you see me and hear me?
Yeah.
Did I answer some questions?
Question?
Yes.
So we have a test this Thursday,
yes.
And then a final next Thursday.
This is the test, like regular semester test for the material which we covered, because we started, as you understand, chapter 3 long time ago. It was quite large, big chapter. Yeah. But the Friday, is it Friday? I don't know if it is Friday or not. Let me look at the calendar.
Next Thursday.
It will be on May 21st. May 21st is not a Friday. It is Thursday on the next week. It is May 21st, please. It is not Friday. It is actually Thursday, again, on the coming week. It will be your final. It is not a test. Yeah, it is a final test, but we call it final.
Okay, thank you.
You're welcome. More questions?
So is the next Tuesday, we still have class or we don't have a class?
No. Our last day of class is also in your syllabus. This is your copy, hard copy of the syllabus long time ago. I told you, I sent you an electronic version. I went through all details during our first class of the semester. But what I'm saying, it is clearly tells you that here, last day of class is the coming Thursday, May 14th. This is the end of semester. After that, we will not have class on the next, let's say, Tuesday, which will be, let's say, 19. We do not have class anymore on 19. 14th is the last day of class during that semester. More questions? Did I answer your question about the coming week? Okay. So, which means we have full hands today of everything. So can we start?
Yes.
Okay. So far, everything what we covered about trigonometry was in the unit trigonometric circle. So, yes, it is really common approach to cover trigonometric functions, their definitions in circles, trigonometric circles. It can be a unit trigonometric circle, or it can be any trigonometric circle with radius not equal to 1, but in circles. If you look at the chapter 4, section 4.1, you probably can do that right now. You can see the topic of this section. It says right triangle trigonometry applications. So it starts on page 251. 251. So let's go to 251. Okay, 251. And chapters 4, first page is page number 250. And the topic for chapter 4 is applications of trigonometric functions. Chapter 4.1 starts on page 251. And you can write today's topic is a right triangle trigonometry. Right triangle trigonometry. And first thing what I'm going to do, as we all the time actually did, is I'm going to define all these trigonometric functions in this right triangle. At the same time, you need to understand that all formulas which we covered, formulas for, let's say, connecting different trigonometric functions, like, for example, sine squared theta plus cosine squared theta equal to 1. Let's say cotangent is equal to 1 over tangent. Tangent is, let's say, equal to sine theta over cosine theta. Absolutely are perfect for triangles as well. We don't need to relearn any new formula. All formulas are working in the triangles as well. Let's say cosine or sine or tangent of double angle or half angle. Again, all these formulas which we learned already, which we covered and worked with different problems applying these formulas, are working for all right triangles. What is the difference? The difference is in definitions of trigonometric functions. Can you please sketch a right triangle? And please name vertices. Usually vertex for the right angle is C. This small square next to that vertex C, it is the international symbol of the right angle. Here, we do not measure our angles in radians, because radians we use only when we use circles. Here in the triangle, we will be talking only about angles in degrees. This is another difference. I am showing small arcs for angle A and angle B because I like to show they can be different, because you can see one arc for angle A and one arc for angle B. Yes, we name angles in geometry, in trigonometry, in any triangle using two different approaches. Or we are using three letters, placing the vertex in the middle, or we just use one letter, which will be its vertex. For example, I'm talking about angle C. How can I write it down? I can write angle ACB, or I can write for the same angle, angle BCA, even though they are in switched form, but you can see all the time I have C letter in the middle. This is the vertex of that angle. Or I can just say that angle C. So here, angle C. Angles are geometric figures. And if you like to say that, for example, angle C is the right angle, what should you do? You can write measure of angle C equals 90 degrees. You can even show that right here in your figure. So M here stands for the abbreviation of word measure. Measure of angle C is 90 degrees. You can see in that triangle, I also have this 90 degrees angle. So that quite often, this is what we do in geometry. Trigonometry is a baby of two parents, algebra and geometry. But as you know, yes, sometimes babies, what they do, characters definitely are very similar to characters of parents. But at the same time, babies in these families have their individual, actually, personal characters, personal, let's say, appearance, and etc. Same thing here in trigonometry. Instead of writing in trigonometry measure of angle C, we will be using the shortest version, or we can write C is 90 degrees. But when we say C is equal to 90 degrees, we do not mean vertex C, because it does not make any sense when we say vertex is 90 degrees. No, we are keeping in our mind in this case that C here represents the measure of the angle with vertex at point C. So this is how we can write it down. We are using here Euclidean geometry. In Euclidean geometry, the sum of all three interior angles of any triangle, including a right triangle, is equal to 180 degrees. So A plus B plus C equals 180 degrees. I can go even further, because we already know that we are dealing with the right triangle. If one angle's measure, like angle C, is 90 degrees, it means that for two other angles, for the sum of their measures, we will be having 180 degrees minus measure of angle C. Measure of angle C is 90 degrees. Therefore, 180 degrees minus 90 degrees will be 90 degrees. What is the meaning of that? It means that any time when you are dealing with the right triangle, two acute angles measures will be all the time equals, I'm talking about the sum of these measures, sum of the measures of two acute angles like angle A and angle B will give you 90 degrees. It means that these two angles, A and B in this triangle, are so-called complementary angles. This is an official terminology which comes from geometry, because in geometry we have a definition of complementary angles as any two angles form a pair of complementary to each other angles if the sum of their measures is 90 degrees. Besides that, we have a definition of so-called supplementary angles. And again, it is only about two angles, not three. The two angles are supplementary if the sum of their measures is equal to 180 degrees. We cannot have supplementary angles in the triangles because for measures of three angles in the sum, we have 180 degrees. But we definitely can have complementary angles, and this is very true for any right triangle. For any right triangle, the sum of measures of acute angles is equal to 90 degrees. I put so much emphasis on this part because later I will show formulas for complementary to each other angles. So, and now I am ready actually to define all 6 trigonometric functions in this triangle. As we know, this side opposite to vertex for the right angle, in our case, it is side AB, is our so-called hypotenuse. Hypotenuse. Hypotenuse is the largest, longest side in this triangle. What do we do usually in geometry and entire math? If the vertex for this angle is capital C, and we never use small case letters for vertices of any triangle, the opposite side can be called side C, but in this case, we are using small case letter. Look what I have here. I have vertex C, vertex for that right triangle in this right angle in this triangle. Opposite side is C. C here is a hypotenuse. And in the same absolutely way, I can name side opposite to vertex A like side A, and side B is opposite to vertex B. Look what I did. I can call these sides by 2 letters. For example, can I call side B like side AC? Definitely I can. Or side, let's say A, can I call it like side CB or BC? Yes, I can. But it will be much more convenient if we can use just one single small case letter naming that sides. So far, so good?
Yeah.
Guys, can you hear me?
Yes.
Today, I don't know why, in my house, I have some problems with internet. This is why I'm very concerned.
We can hear you, but the picture is kind of frozen a little bit.
I honestly, the speech was so unclear. I mean, the sound of that. Did you ask me a question?
No, I did not ask you questions, so I just let you know because a lot of times it's like it's kind of your internet is very slow. I think.
You know, but this is what I'm telling you. I don't know. After I finish my work, I definitely will be forced to call the internet company to see what is going on. I have problems today with internet, and I don't know.
Thank you.
Okay, so this is what we have. Because it is a right triangle, we can use here Pythagorean Theorem, which we also used when we started defining our trigonometric functions in our trigonometric circles. So according to the Pythagorean Theorem, a squared plus b squared equals to c squared, because we have here a hypotenuse, which is side C, and we have here two legs of that triangle, legs A and B. This why we definitely have this Pythagorean formula. A squared plus b squared equals to c squared. And now I'm ready to start. Let's say our angle A is alpha. Can we use Greek letters to rename angles? Yes, we can. Letter beta I will use to represent angle B. And the other one is, let's say, gamma. Alpha, beta, gamma, first three letters of Greek alphabet, like A, B, C are three letters of Latin alphabet. So practically, if you like to write previous statements about angles of this triangle, what can we write? For example, instead of A plus B plus C equals to 180, I can write alpha plus beta plus gamma equals to 180 degrees. Or alpha plus beta equals to 90 degrees. I can write alpha plus beta equals to 90 degrees. Alpha plus beta plus gamma is 180 because angle A is alpha. I'm talking about their measures. B's measure is beta and C's measure is gamma. So I am going to define right now the first function, which is sine. And let's say I'm doing for angle alpha. So for alpha, what do we have? Sine alpha. I'm going to write all these functions, cosine alpha in the column. Tangent alpha, cotangent alpha, secant alpha, cosecant alpha. And now I am going to define each of these functions using sides of that triangle. First, all these functions are ratios. So which means this is practically similar absolutely to what we did in the circle. Only instead of sides, we were using coordinates of the endpoint of the terminal side for each angle. So it will be opposite side, and I'm even writing this with letters. All the time in any right triangle, sine of any angle equal to opposite side over hypotenuse. This I even wrote their abbreviations. OPP, opposite side over hypotenuse. Opposite side for alpha is A, hypotenuse is C. So practically in this triangle, sine alpha is A over C. I immediately can actually write definition for cosecant alpha, because cosecant, as we already learned long time ago, is the reciprocal of sine. So it will be hypotenuse over opposite side. So it will be C over A. And I already have this also. It was A over C in the first place. On the last one, it is C over A. Cosine. Cosine is adjacent side over hypotenuse. If you look at this triangle as a figure, what do you see here for angle alpha? For alpha, we had A as an opposite side, but angle alpha is formed by two sides, B and C. C is a hypotenuse, so B is so-called adjacent side for A. So in this case, it will be B over C. Again, another ratio. Because cosine is B over C, so secant is hypotenuse over adjacent side, which is C over B. Because here, again, all formulas are working in the same way as we learned in our trigonometric circles. Tangent. Tangent is also a ratio. It is a ratio of the opposite side to, excuse me, talking too loudly, adjacent side. So no hypotenuse in it will be adjacent side over, opposite side over adjacent side. So which means it will be A over B, A over B. Cotangent is a reciprocal, so it will be adjacent side over opposite side. So which will be B over A, and these are definitions for angle alpha. In terms of A, B, and C sides. But here I am going to box that part which will be working for any angle. You will see right now what I'm boxing. It is verbal part of definition. Verbal part of definition, like opposite side to hypotenuse, or adjacent side ratio to hypotenuse, or opposite over adjacent, or adjacent over opposite. These are universal definitions which will work for any angle in the triangle. For example, 90 degrees angle, sine will be equal to opposite side to hypotenuse. Opposite side for angle C or gamma is C, so it will be C over C, which will be 1. Is it true that sine of 90 degrees is 1?
Yep.
That's it. You can see everything is working. So now, same formulas which we covered for sine of, or not only sine, all trigonometric values for 30 degrees, for 45 degrees, for 60 degrees, for 90 degrees are perfectly working here. So you don't need to relearn any values. You just need to repeat that values, which we covered long time ago at the beginning of semester, knowing all these values, because they will be same values for this triangle, triangles, angles. The only thing, again, difference here, we do not measure angles in radians. We measure them only in degrees, which makes sense. Now, in the same manner, I'm going to write, let's say, definitions for angle beta. And I will be using, again, that boxed definitions, verbal part of definition. So, for example, for angle beta, opposite sides this time will be side B. So sine of beta equals B over C. Cosine of angle beta equal in the same way as we did it for cosine alpha, adjacent side over hypotenuse. Adjacent side for beta as an angle, it is A, so it will be A over C. So tangent of beta will be opposite side. Opposite side for beta is B. Adjacent side is A. So, and look what we have. You can see we are using same definitions which you see in the box, but they in the fractional form, they look different because angle alpha and beta, they have different opposite and adjacent sides. So this is what you need to memorize. The verbal definitions of these functions, like opposite side to hypotenuse. What is that? Sine of that angle. Or let's say opposite side over adjacent side. What is that? It is a tangent of that angle. And so on. And I can write this second column for beta, which is cotangent beta, which will be adjacent side over opposite. So it will be A over B for that particular angle beta. Secants in the same way will be verbally looking like reciprocal for cosine, but it will be hypotenuse over adjacent side. And finally, cosecants. Just 1 second. I'm going to do that like in the box. Yeah, and I will show it to you right now. So it is cosecants is the last one. And this is the reciprocal for our sine. So I wrote all this in these boxes. They are all 6 trigonometric functions. You can find all these definitions on page 251, also like on the bottom of that particular page, 251. So here in this section, you can find quite many interesting problems solved as examples. I really recommend you to go over these examples. But now I'm on page number 259. Page number 259. And I will be solving right now some problems and definitely giving you full explanation. So, page 259, I wrote it on my paper. I'm going to solve right now problems from 19 to 28. In problems 19 through 28, find the exact value of each expression. Do not use a calculator. Okay, and let's say I'm solving problem number 19. What do I have on problem 19? Sine of 38 degrees minus cosine of 58 degrees. This is the problem number 19. Sine of 38 degrees minus cosine of...
It says 52.
Let me... Oh, you are absolutely correct. Thank you very much. Thank you. I just copied accidentally, not correctly. I thank you again. Thank you for your help. Sine of 38 degrees minus cosine of 52 degrees. And if you precisely look at these angles, they, from the first glance, they look very unattractive, because 38 degrees, if we have 30 degrees, we should know sine of 30 degrees is 1/2. Or let's say cosine of 45 degrees, but not 52 degrees. What should we do? There is a trick. If you add these degrees to each other, 38 degrees and 52 degrees, what do you get?
90.
Absolutely, yes. But if the sum of two measures of two angles gives us 90 degrees, are they complementary angles to each other?
Yep.
And you know what? There is a trick, because sine of one angle will be equal to the cosine of its complementary, or tangent of one angle will be equal to cotangent of its complementary. Do you understand that? In our case, alpha and beta, they were complementary angles. I can even box that, what I just wrote previously. It is right above that definition. Can you see? Alpha plus beta is 90 degrees. This why I am going to write another box here on the side, which we will be using solving this problem. So for this particular triangle, because alpha and beta are complementary to each other angles, sine of alpha will be equal to cosine of beta. Or if you like, sine of beta will be, just one second, or sine of beta will be equal to cosine of alpha, and so on. I'm not going to write all this, but at least the most important. So tangent of alpha equals to cotangent of beta. So one function of that from the pair of complementary will be equal to its co-function of its complementary angle. So this, for example, secant of alpha will be equal to cosecant of beta. And this is, again, and you can write this, just one second, please, or tangent of beta equals to cotangent of alpha, or secant of beta equals to cosecant of alpha. And I wrote it right here on the side. Sine of alpha equals to cosine beta. Why? Because alpha and beta are complementary. Or let's say y tangent beta equal to cotangent alpha, because again, beta and alpha are complementary to each other angles. This y, are you copying that formulas, guys? Are you done?
No.
Okay. This why I'm asking you. It is enough to write just first column because the second one is quite similar, but I just wanted to show you all versions. This is why I wrote 6 identities, 6 formulas. It is enough to write just 3. So, would you like to keep in your problem 38 degrees or 52 degrees?
38 degrees.
So copy the first part, sine of 38 degrees. And you will be not copying anymore cosine of 52 degrees. To 52 degrees, which angle is complementary? You can easily find it subtracting 52 from 90 degrees. 90 degrees minus 52 degrees exactly equals to 38 degrees. Is it correct?
Yep.
Yes.
So this way, please replace cosine of 52 degrees by sine of complementary angles, which is sine of 38 degrees. So which means we use these formulas, and now we have sine of 38 degrees minus cosine was replaced by sine of 38 degrees. Cosine 52 degrees disappeared. Sine of 38 degrees minus another same sine of 38 degrees. Is it 0?
Yep.
That's it. And we don't need any calculator. Otherwise, we would not be able, if we had, let's say, 38 degrees and 60 degrees, we would not be able to solve this problem without calculator. But here we can. I will show you another problem right now. Let's say this is problem number 22 from the same spot. What do we have here? Cosine of 40 degrees divided by sine of 50 degrees. And again, we cannot use any device like, let's say, calculator, computer to do that. We need to use our own brains and formulas. I immediately look at these angles. One angle is 40 degrees angle, another is 50 degrees, and I'm trying to see if they are complementary or not. Are they?
Yep.
That's it. These two angles are complementary to each other because 40 degrees plus 50 degrees is 90 degrees. Now you just need to choose one or the other one. You can choose 40 degrees if you like. You can choose 50 degrees if you like to proceed. Which one would you like to keep?
40 degrees.
So 40 degrees, you said, so on the top, just copy cosine of 40 degrees. But you will be not copying sine of 50 anymore. You will be replacing this by something different. And what should I write instead of sine of 50? What is the cofunction for sine? Guys, you do not know the answer?
Can
About
you repeat the question again?
what is the cofunction for function sine?
Cosine?
Definitely. Even their names for sine cofunction is cosine. For cosine, cofunction is sine. For tangent, it is cotangent. Even their names tell us about that. For cotangent, cofunction is tangent. For secant, it is cosecant. For cosecant, it is secant. So which means I need to replace now what I have here in denominator by its cofunction. What is cofunction? Cosine. And now I am not going to write 50 degrees anymore. If I switch to cofunction, I need to write now new angle, which will be a complementary for 50 degrees. What kind of angle is complementary to 50 degrees? It is 40 degrees, right?
Yeah.
So bottom now is in the switched form. It is now on the bottom. I have cosine of 40 degrees. So this y on the top I have cosine of 40 degrees. On the bottom I have cosine of 40 degrees. Is it ratio equal to 1?
Yeah.
That's it. This is the answer. How do you like these problems? I think they are awesome.
Yep.
You know what? Actually, look, now we have another actual explanation for the fact which we learned a long time ago. What is the sine of 45 degrees? Is it square root of 2 over 2?
Yeah.
What is the cosine of 45 degrees? Is it also square root of 2 over 2?
Yeah.
Do you understand that 45 degrees has complementary angle to it also, which is 45 degrees. So 45 degrees is complementary to itself because 45 degrees plus 45 degrees is 90 degrees, right?
Yeah.
And this is why we can explain that cofunctions of complementary to each other angles are equal. So which means sine of 45 degrees should be equal to cosine of complementary. Complementary is also 45. So cosine of 45 degrees equal to cosine of 45 degrees. Another example, 30 degrees and 60 degrees. Sine of 30 degrees will be equal to cosine of 60 degrees. Because sine of 30 degrees is 1/2, cosine of 60 degrees is also 1/2. So now you have another very fresh point of view on the values which you covered long time ago. So if you accidentally, let's just pretend that you forgot the value of cosine of 60 degrees. Knowing these formulas, we need to recall this formula saying, oh, that cosine of 60 degrees is equal to sine of 30 degrees. At least you need to remember that sine is 30 degrees is 1/2, and immediately you can say, oh, cosine of 60 degrees is 1/2. Or let's say tangent of 10, I'm just giving you independent examples. Let's say tangent of 10 degrees. Tangent of 10 degrees will be equal to cotangent of 80 degrees. Why? For the same reason, because 10 degrees and 80 degrees are complementary to each other. Is it clicking?
Yeah.
Mhm.
And I will solve another problem. Which one would you like to see? 26, 27, or 28? Just choose one.
28.
28. Okay, thank you. And I'm going to copy. So secants of 35 degrees times cosecants of 55 degrees minus tangent of 35 degrees times cotangent of 55 degrees. I hope I copied correctly. Secants of 35 times cosecants of 55 degrees minus tangent of 35 degrees times cotangent of 55 degrees. Did you copy the problem?
Yes.
Yeah.
Let's talk. You see here two different angles, 35 degrees angle, 55 degrees angle. Which one would you like to leave in your problem? But guys, first add these two angles, 35 degrees plus 55 degrees. What do you get? What do you get as a result of this addition?
90 degrees.
That's it. Can we assume now, saying that we are dealing here with two complementary to each other angles?
Uh-huh.
Next, so this was your first question. Are these angles complementary? We answered yes, adding just these two measures in degrees. Second, which one would you like to leave in the problem to say warm goodbye to another one? Would you like to keep 35 to proceed or 55 degrees?
35.
Thank you, Bhaktima. So everything carrying 35 degrees will be unchanged, but everything carrying 55 degrees should be switched to its co-function of 35. So secants, yes, I'm copying secants of 35 degrees, but not cosecants. What should I write instead of cosecants?
Secants.
Right.
35 degrees.
Secants of what?
35 degrees.
Accepted, absolutely, yes. So basically, in the third spot, now I have secants of 35 degrees times itself, secants of 35 degrees. Let's move to the next product. As you understand, we decided to keep everything with 35. So copy tangent of 35 degrees. Should I copy cotangent?
It should be tangent 35
Right. So
degrees.
the answer to my question was no, right? Because I asked what? Should we keep cotangent? No. What should we write instead of cotangent? What is the co-function?
Tangent.
Tangent. The tangent of what?
35.
Absolutely, yes. And now we have this secants of 35 by itself, tangent of 35 by itself. If we multiply same by same, is it square of that?
Yes.
So write down secant squared of 35 minus tangent squared of 35. We have here different now methods to continue, but one of the easiest method is, did we learn long time ago any formula in which we saw both in secant square and tangent square? Answer is yes. We have that formula in possession. So what kind of formula? Secant square of theta equal to what?
Tangent square plus
Yes.
1.
Yeah, replace secant square of that angle by what? Tangent square of 35 degrees plus 1. This is your secant squared. This is what I wrote instead of secant. Tangent square of 35 degrees plus 1. But I need to continue minus tangent square of 35 degrees, which I already had. So I got tangent square of 35 degrees plus 1 minus tangent square of 35 degrees. Can we cancel tangent squared?
Yes.
Because they are opposite to each other. What is left?
1.
And which is the answer? Did you understand how to work with these problems?
Yeah.
Excellent. Now, ladies and gentlemen, can I, with your permission, move to other spot to solve more problems?
Yes.
Okay, let's do that. Have your calculators in your hands, in the case, if we need them. So, and if you can have something like a ruler also, because we will be sketching so many right triangles here. I'm now grabbing something from 9 through 18, and this is already a different page. Very soon we will have 5 minutes break, and after that we will continue. This is again same page 259, and problems here from 9 to 18. In problems 9 through 18, find the exact value of the 6 trigonometric functions of the angle theta in each figure. I am going to show right now, let's say how to solve, let's say problem number 12. Are you okay with that?
Yeah.
Please write down the page number 12, and please copy that figure because we need to show that triangle. This is why I grabbed that small ruler, because I really like to have quite good looking figure. Okay, I will show that angle theta. I will show that right angle here, and I'm writing 3 and 3. So this is my figure. So look what I'm going to do. I will name vertices and sides Please do that in the same manner as we did before. For opposite vertex, for the sides opposite to the certain vertex, please use the same letter, only small case. So far, so good?
Yes.
And what did they ask us about here? They asked us to find values of all 6 trigonometric functions for this particular triangle. But look here. I have 2 sides. I have here 2 legs. Do we know the hypotenuse here?
No.
So,
So first step, let's find it. So I'm writing down a squared plus b squared equals c squared. A is 3, so it will be 9 because it is square of 3 plus another square of 3. 9 equals to c squared, which means c squared equals to 18 square root from both sides, and I'm having C here. There is no plus minus version because side length of the side cannot be negative. It is all the time here taking square root, you are getting only positive result. So it will be square root of 18. 18, is it 9 times 2?
Yeah.
Can we take 3 out of square root out of 9?
Yes.
Yeah.
Voila, this is your C. I'm boxing that to make it visual. It is not the answer. It is just value for C. C, it is our hypotenuse equals 3 square root of 2. That's it. I'm equipped by everything. So I'm starting with sine theta. Sine theta equals A over C, which is opposite side for theta, which will be equal 3 over 3 square root of 2. Cancel both 3's, so it is 1 over square root of 2, or you can show that, or you can assume that people will understand what you do. Multiply top and the bottom by square root of 2, and voila, you are getting sine of this theta equals square root of 2 over 2. Which actually makes sense, because can you critically look at this triangle? Can you see 2 legs have length equal to 3?
Yeah.
Yes.
It can happen only in one case. If your triangle is an isosceles triangle. What is the meaning of isosceles triangle? Isosceles triangle is a triangle in which 2 sides have equal length. In this case, 2 base angles are also congruent, which means if theta, which is angle A, and the other is angle B, angle A and angle B are congruent. It means they have same measures. It means that each one is 45 degrees angle because they should be complementary. If 2 angles are complementary and they have same measures, it can be only 45 and 45 degrees. Do we know that sine of 45 degrees is square root of 2 over 2?
Yes.
Yeah.
Which means this result makes sense. So, and we can continue in the same manner. If we know already value of sine theta, can we write that cosecant theta is 2 over square root of 2, which is square root of 2. I can now find cosine theta. Cosine theta equals to adjacent side, which is B, over hypotenuse. And it is also actually 3 over square root of 2. And I know it is same thing like we got for sine. So it will be square root of 2 over 2. And because of that, secants also will be equal to square root of 2. So I already have this value. I am left only with tangent and cotangent, and it will be very easy because I have all information about all sides. Did you have an opportunity to write it down?
Yeah.
Yes.
Okay, so tangent theta equals opposite side, which is A, over adjacent side, which is B. It is 3 over 3, and it is 1. So which means its reciprocal, which is cotangent theta, also will be equal to 1 divided by 1, which is 1. And well, I solved completely entire problem. Did you understand the process?
Mm-hmm.
Excellent. Let me quickly, I am declaring the break, but before I I'll let you go. Can you please? Can you please stay as soon as you hear your name? You can actually leave. So today is the 12th. Bryce,
Here.
Gracia,
Here.
Alexia, Hannah.
Here.
Okay. Dimitar.
Here.
Thank you. So, Ariana,
Here.
Axel,
Here.
Desiree, Bhaktima,
Here.
Jessica,
Here.
Ivona,
Here.
Devin, and Valeria.
Here.
Okay. And you can rest, and I will continue in few minutes. Actually, at 11:20, because unfortunately today will be a little bit shorter break.
Professor,
Yes.
for the final next Thursday, it's cumulative, right?
Final definitely is cumulative.
Okay.
The coming test, which we are going to have on this week, I will not include chapter 4 material.
Okay. Okay.
It will be for what we learn in chapter 3,
Okay.
like inverse functions, formulas for sum and difference of angles, double angles, half angles. You know, we covered many different things
Okay.
in chapter 3. It is a really huge, big, as I call it, monstrous chapter in this textbook.
Okay. Thank you.
You're welcome. Okay, ladies and gentlemen, can I continue? I am willing to solve right now another problem, which will look slightly different because in this problem, we had an information about two legs, and now I would like to solve something slightly different. Can I?
Yeah.
Okay. Let's say problem number 17 in this, from this section. Please immediately sketch that triangle, which you see here. The difference here is we will be sketching too many triangles, solving problems. As we before that were sketching circles, now we are doing this work with triangles. So it is again a right angle. Traditionally, we name that vertex for the right angle with like C vertex. And two others are up to you. So this what you actually have in your textbook as a triangle. You can see I immediately already placed that C here. So the opposite side is our hypotenuse. So square root of 5 is our small case C. And what would you like? What kind of letter you need to use to name the vertex for angle theta? You can use A, you can use B, up to you. Which one?
B.
B. Okay, B. So this what we have here. So which means now I am equipped by these vertices. I will call the opposite side for angle A like small case A side, and that one which has length equal to 1, opposite to angle B, this is my B side. So now I'm equipped by all these small letters A, B, and C representing sides of that triangle. What do I see here? This is a slightly different problem. We are going to use same definitions, but in the first problem, which was number 12, we had information about two legs. We did not know anything about hypotenuse. We found the hypotenuse in the process of solving. But here, hypotenuse is given, and one leg is also given. Okay, but we are going to start again with Pythagorean Theorem. A squared plus B squared equals to C squared. And we will plug our numbers which we have. A is not known, so I'm just writing A squared plus B squared. B is 1. Does it mean that it will be B squared equal again to 1?
Yeah.
C is square root of 5. If you square root of 5, what do you get?
25. Oh, 5.
That's it. This is what I wrote. And I'm going to solve it for A. So can I say that A squared equals 5 minus 1, which means A squared equal to 4? If I take square root from both sides, voila, I have A equals to 2. I already know that A is equal to 2. This was my first step here. I was looking for A because it was missing, and I found that value right now, value for A. A is 2. So the length of that side A is 2. Am I equipped by all three sides right now?
Yep.
Can I start using definition of all trigonometric functions for angle theta to find their values?
Mm-hmm.
Let's do that. Sine theta. What is the opposite side? Is it B?
Yep.
B over C, because C is a hypotenuse, and I'm plugging numbers right now. B is 1, hypotenuse is square root of 5, so I got 1 over square root of 5, but I will not keep this as a final answer because I cannot. I need to get rid of that root downstairs, so I'm going to multiply top and the bottom by square root of 5, and I'm getting square root of 5 on the top. Square root of 5 times square root of 5, it is square root of 5 squared, which is 5. So, and I have already that value. Sine of theta is square root of 5 over 5. Did you understand the process?
Yeah.
Immediately, I write down cosecant is equal to 5 over square root of 5. 5 over square root of 5 is square root of 5. Because square root of 5 squared is 5. I can replace 5 by square root of 5 squared, cancel 1 power, and this is what I am getting. Or you can use that information that it was 1 over square root of 5 originally. It means cosecant will be square root of 5 over 1, which is square root of 5. The next candidate is cosine. Cosine. I really apologize. Instead of theta, I wrote alpha. Can you switch all these alphas for theta? Because in our problem, I really apologize. It is my fault. I renamed that angle, please. I already switched, changing alpha for theta. Talking too much. So now cosine for theta, adjacent side is A. So it is A over C. A, we found it was 2. C was given square root of 5. So it is 2 over square root of 5. In the same manner, I can multiply top and the bottom by square root of 5. And I will get here 2 square root of 5 over 5. And this is my cosine 2 square root of 5 over 5. After that, the next candidate, secant theta. Secant theta is square root of 5 over 2. I used that version of the answer for cosine theta before I got rid of, I switched from square root of 5 in denominator for cosine for a better acceptable form in math. So next two candidates are tangent and cotangent. Last pair, tangent theta equals to opposite side, for theta it is B, over adjacent side, adjacent leg is A, and I will plug there that information. B is 1, and we found A equal to 2, so this is 1/2, which lets me easily find now cotangent value, because it is reciprocal for 1/2. Reciprocal for 1/2 is 2. And I'm completely done with the problem. What do you think about this section, guys?
Better.
But we will have here some word problems as well. So can I on your behalf, definitely talking on your behalf, can say that you are okay with that material and I can move to another spot, solving
Yeah.
more problems, can I?
Yeah.
Mhm.
Again, please, if you feel that answer is no, tell me about that. Can I?
Yes.
Thank you. You are very kind. So I need another piece of paper. Can I remove that paper?
Yep.
Okay. So I'm going to do right now, I'm going to solve right now problems which we call in math solving triangles problem. For people who are not familiar with trigonometry, with math, with geometry, it can sound a little bit ridiculous. What does it mean, solving triangles? Because we can sketch triangles, we can look at the triangles, we can name triangles, but what is the meaning of solve triangles? Yeah, we say that, but what do we mean? Solving triangles in math means find all missing parts of that triangle. Do you understand what it means? It is like translation from a regular language into mathematical language. Again, solving triangles means finding all its missing parts. In any triangle, we have 3 sides and 3 angles. Okay. This is the spot from number 29 to 42. In problems 29 through 42, use the right triangle shown below. Then, using the given information, solve the triangle. Let's do that. Let's say that we need to work with problem number 30. Again, same page, 259, problem number 30. First, sketch that triangle, please. So, only I will recommend you to do something better than the book has. Please don't write down A, capital B, etc. inside of this triangle. Let's do that in more appropriate way, because they are trying to show us angles, but we know that we can call angles by vertices, by their vertices. So let's do that again in a little bit nicer way. So sketch that right triangle, and I don't know why they do not have vertex for C. This is what I showed. This is actually a little bit better way. And name opposite sides by proper letters. So mark angles to other angles. And this is the figure which we are going to use right now to solve this problem. Now, what do I do here? What should I do here? I'm going to write given. So B is 4. Capital B is 10 degrees. Find A, C, A, given B is 4, B angle is 10 degrees, find sides A, C, and angle A. Are you with me?
Yes.
Yes.
Excellent. I'm going to call each angle by its vertex. Is it legal? Yes. This why, look what I'm going to start with. A plus B plus C is 180 degrees. Is it correct?
Yep.
Yes.
What do we know? We do not know measure of angle A. What about B? Is it 10 degrees?
Yep.
C, is it 90 degrees?
Yes.
And look what we have. We have very easy equation. A plus 10 degrees plus 90 degrees equals 180 degrees. Don't forget to use symbol of degree, please. So 10 degrees plus 90 degrees, is it 100 degrees?
Yep.
So A equals 180 degrees minus 100 degrees. A is equal to 80 degrees. Box it. Did I find already one missing part?
Yep.
Yeah.
So which means we now are equipped by all three angles. One is 10 degrees, another is 80 degrees, another is 90 degrees. Could you do that in different way? Yes. In any triangle, we have one 90 degrees angle, which means two others will be complementary. I just use traditional way, but you could do that in different way. I'm writing here below that triangle, or you can write A plus B is 90 degrees because there are two complementary angles all the time in triangle. So B was 10, so A plus 10. If I were you, I would probably use this way because it is even easier. So A is equal to 90 minus 10 degrees equals to 80 degrees. So we are getting same thing, but I wrote here or the other way. And again, I like the second way even better. This what we wrote, or, traditional and elegant, two different approaches. Now, what do we need to find? We need to find A and C sides. Now it is up to you, but I would like to give you a recommendation. Because we already know the measure of angle A, but B measure was given in your problem. It was already given. I would probably use that B angle. Definitely, if you like, you can use A angle, because if you are absolutely sure that you found that information for angle A correctly, it doesn't matter. You will be proceeding using correct details. But again, my recommendation, try to better use that parts of triangle which were given originally in the problem. So this why I am going to write for angle B, for B, let's say, what do I have? I know that the opposite side is 4. You can even show that in your triangle. Make it more visual. Look what I am adding to that figure. I added 10 degrees and I wrote B is equal to 4 right next to that side of triangle. So C here is a hypotenuse. And can I use, let's say, definition of the sine of that 10 degrees angle? Yes. B had 10 degrees, so which means sine of 10 degrees equals, is it opposite side, which is B, over hypotenuse, which is C? Yes?
Yeah.
I'm going to plug, instead of B, I'm going to plug 4. So which means sine of 10 degrees equals 4 over C. And I have only one missing C value in the last form. It is like simple equation. What can I do? I can find that C easily. Multiply both sides by C. Cancel on the right, and you have C times sine 10 degrees equal to 4. And I need to solve it for C. Can I divide both sides by sine of 10?
Mm-hmm.
All right. Sine of 10 degrees. Cancel them on the left side and plug what you have on the right in your calculator. Grab your calculator. Immediately check the mode of the calculator, because in the previous chapter we were using radians. My calculator is in the radians mode, so I will highlight that third line and I will use arrows from radians to switch to degrees and push enter. Now my calculator is in degree mode. You can see it is flashing. Go back to home screen. And now you are ready to enter that. So C approximately equals 4 divided by sine of, in parentheses, just enter 10, 4 divided by sine of 10, it means 10 degrees, and push enter. And I have approximately, they did not tell us how to approximate. Let's say approximate to the nearest 100. 23 point, we have 0.35, so I will increase that to 4. So 23.04. And I have that information. You can box it because it is your missing C, which you had in your problem like an unknown. Box it. Now we are left only with A, and I can find A value as well. Now it is up to you again what to use, because you're already equipped by hypotenuse. If you like, you can use, let's say, cosine of 10 degrees. If you like, you can use sine of A angle, 80 degrees. You can use tangent, because again, you found your A. You need to find your A. B was given. I would probably use here tangent of 10 degrees, because we have tangent in our calculators. Preferably try to use sine, cosine, and tangent, because we have them already in your calculators. This is why I'm going to write again for same angle 10. I'm going to use tangent of that angle. Tangent of 10 degrees equals opposite side, which is B, over A. B is 4, and here A is A. So tangent of 10 degrees equal to 4 over A. Excellent. I will write it one more time. On the next line, tangent 10 degrees, 4 over A. And I need to find A. How? In the same manner as I found C, multiply both sides by A. Cancel A's on the right side. You have here now A times tangent 10 degrees equal to 4. Divide both sides by tangent of 10 degrees. And you are getting A, cancel tangents on the left, and you have A equals 4 over tangent of 10 degrees. This is your value for A, which we are going to approximate right now. A equals 4 divided by tangent of 10 degrees. Grab your calculator and enter this exactly how it looks on your paper. 4 divided by tangent of 10 degrees. 4 over tangent of 10 degrees, and enter. 22.5 It is 685, so it is 69. So this is your value for a 22.69. And we are done. We solved entire triangle. Did you understand the process?
Yeah.
I would say right now a few words. Probably I will not have enough time to solve entirely problem number 42, but at least I will start. Is it okay if I, saving some time will not be actually, no, I will sketch. I wanted to just to do that a little bit faster, but please, we need to sketch that triangle each time because we will have different given parts in each of these triangles. So let's do that. What do we have here? In this triangle, we have B, A, C, and we have A, C, and B. This is what I first did. I have now that triangle to start. What do we have here? We have B equal to 4 in problem number 42. C equals to 6. And that's it. I do not have any other information just for two sides. Excellent. Given B is 4, C is 6. Find what? Find side A, angle A, and angle B. Oops. So now I have this in front of my eyes, the figure with given parts. I'm going to first find A. Can we use Pythagorean Theorem?
Yes.
Yeah. So A squared, B is 4, 4 squared is 16. C is 6, squared is 36, right? A squared equals 36 minus 16 is 20. A squared equals to 20. Square root from both sides. 20, is it 4 times 5?
Yep.
So, and I already have first answer. A is equal to square root of the 2 times square root of 5. Using Pythagorean theorem. Now I am going to look for angles. When I am equipped by all three sides, finding angles is not so bad. Let's say I decided to first find, let's say, angle B. It's okay. What do I have for angle B? I have opposite side and I have a hypotenuse. Is it good enough to write that sign B equals B over C, guys?
Mm-hmm.
Plug your values. So you are getting sine of B equals 4 over 6. Definitely, I will not keep it like that. 4 over 6, I will reduce. Is it 2/3?
Yep.
Sine of B is 2/3. Look now what we are going to do. I'm going to apply arc sine to both sides. So arc sine of B equals arc sine of 2/3. This what we learned long time ago, and this is what we are going to use right now. So B equals arc sine of 2/3. Grab your calculator and enter that information in the calculator. So press the second button, press the sine button, arc sine is released, enter 2 divided by 3, close parenthesis, and push enter. And you are getting 41.81. Okay, so usually we round our angles to the nearest tenth, sides to the nearest 100, angles to the nearest 10. So it is approximately 41.8 degrees. And actually I found already B. Actually, I will finish that problem right now. So, and now what can I do? I can do in the same manner with arcuses to find A, because for example, I can write that cosine of A is B over 4. It is also 2/3. So basically A is equal to arc cosine, but I will not do that because do we know that A and B are complementary to each other angles?
Uh-huh.
Using much easier way. Why should I use arc cosine? Arcuses, if I can do that easier, I will write A plus B equals 90 degrees. Then A equals, is it 90 degrees minus B?
Yep.
And I will plug right now value of B right here. So, which means A approximately equals 90 degrees minus 41.8 degrees. And use the calculator if you don't want to do that in your mind. 90 minus 41.8. I accidentally entered this incorrectly. 90 minus 41. I skipped that one accidentally. 90 minus, it is 41.8 degrees is 48.2 degrees. And I found the last missing value, last missing item, and I'm done. I completely solved that problem. But I kept you a little bit longer, just few minutes, about 2-3 minutes longer. With your permission, can I end today's
Yes.
class?
Yeah.
Yes.
Please, 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 please try to review seriously all values and all formulas, because it will be for you much more comfortable if you are confident about what you covered in chapter number 3. Okay? And please pay attention to what kind of emails you will get, because I will write down more details what to do with that test. Okay?
Okay.
Okay, guys, have a nice, beautiful day, and I will see you the next time.
Thank you.
Stay safe and well.
Thank you.
Yeah, everyone, nice, happy day today.